Attendees are in listen-only mode.
Well, good afternoon, everyone, and I appreciate your time and attendance today to our webinar, Eliminating Pain in Your CAD Design Process. My name is Rob Romanowski. I am the Director of Operations for 3HTI, and I'm joined today with Bruce Bodnick, our Senior Technical Director. So what we want to do today is basically this presentation is specifically for pro engineer customers to give them a little more insights to Creo 3.0. And this is also in conjunction with a promotion that PTC is having that they've entitled their Get Active campaign for those customers who have had their support lapse over the past several years. If you're using a version of Pro Engineer, there is an opportunity to be able to upgrade to Creo 3.0. And I'm going to discuss those details a little later in the presentation. Everybody's going to be on mute during the presentation, but feel free to type questions in the dashboard for the question box. And I don't want to make this death by PowerPoint. I just want to go over a few highlighted, a quick highlighted overview about Creo 3.0. Which pertains specifically to what you're going to see. I'm not going to go into everything about Creo 3.0. If we can get done in less than an hour, I think we would all be happy, and I think that's the goal. So anyway, I must apologize because I tried to, I was attempting to run a slideshow so you could see my entire screen, but for some reason, PowerPoint is not being kind to me today. So anyway, I'm just going to have this. Hopefully everybody can see it fine. And let me go into the next slide. So basically, as a company, our mission is to help people live better lives. We want to help our customers maintain a competitive advantage within their industry. And what that means is not only providing the right tools to do the job, but becoming a partner with our customers. And it doesn't matter if you have one seat of software or if you have 100. We want to help you achieve your goals with your company and make sure that you're utilizing and maximizing tools like Pro Engineer or Creo 3.0 so that you can ultimately get your work done faster, help your customers faster, be more efficient, and improve your profitability. So the slides that I've hidden are now showing, and I really didn't want to do that, so I apologize for this. So basically, what is new in Creo 3.0? So the three areas that we're going to discuss are the MultiCAD technology, which is also known as Unite technology, improvements in concept design, and also improvements with flexible modeling, and that goes into the core productivity of Creo itself. So I think the first thing I need to do before I get into just a little bit more about Unite technology, there's been some questions like what exactly is Creo and what does Creo do? So Creo is basically constructed on the Granite kernel that runs Pro Engineer. And in 2007, PTC had purchased a direct modeling software from Hewlett-Packard called Co-Create. And direct modeling is basically modeling of geometry only. There's no model trees. And this code was written on the Granite kernel. So basically it gives the Creo user a geometry only or direct modeling capability, but you're still in a parametric setting. So what this allows you to do, we'll see more of this this affects everything as far as Unite technology, what we're going to look at with freestyle in concept design, as well as for flexible modeling. This allows you to be able to create concepts fast, make late stage design changes quickly, and also be able to import models from files from other CAD systems and be able to edit those files so it recognizes the geometries, so they're not 100% dumb files. And then what you have the ability to do is after creating these files is then you can add the parametric intelligence to to the files when it makes sense. So you could come up with 3 or 4 concepts, and then rather than having to come up with 3 or 4 concepts and taking a little more time because they're built in a parametric setting, you're doing them quickly in a direct modeling setting, and then you can just add the parametric intelligence to the concepts that you're going to move forward with. So I hope that makes sense. So basically with Unite technology, this enables you to be able to efficiently convert all non-Creo data from other CAD systems. And you can easily incorporate that data into existing designs. You can also create and maintain design intent between Creo and other non-Creo formats. And you're going to see Bruce is going to show you how to do this today. And also you can share PTC Creo data in the most common CAD formats. So part of the issue with data migration in a lot of cases is if you bring in a file like a step file or an IGES file, you have to convert that file right up front. And that's a lot of time, and time obviously is money. But one of the thing with Unite technology is when you bring in this file, because it's a SOLIDWORKS file or it's an AutoCAD file, when you bring it into Creo 3.0, you can take your time to model whatever or convert whatever portion of that assembly you need to. And that gives you some more flexibility and helps to save money in the long run as far as your efforts in taking that file and bringing it into your current assembly or an assembly from another system into to convert to Creo. So this right here shows an import of Creo itself. So basically, you can import data from 5 CAD systems, from SOLIDWORKS, CATIA, Unigraphics, Inventor, and Solid Edge. When you import, basically, as an example, if you're importing, say, a CATIA file into Creo, it creates a duplicate data in Creo that becomes Creo data. And the advantage is that can work with data in Creo, but also doubles the amount of data to keep up to date. When the changes are made, you need to re-import the data to incorporate the changes. Now, when you open a file, you can open them, the model tree, native icons, and no duplicate data. You can just make modifications to the data itself. When the part is changed, that part is changed on demand. You don't need to convert it. You can just change things when the modification is needed. And once again, Bruce is going to go into this, but sometimes I know me personally, I need to hear things a couple of times before it actually sinks in. If you want to save as a file, if you want to save the file as you can save it as a SOLIDWORKS file, as a Unigraphics file, or a CATIA file, but you need a collaboration extension. So you could take this PTC Creo file and save it as one of these other 3 files. So for concept design, for those of you who may not be aware, but Creo, back with Creo 2.0, the release of 2.0, they had this pretty neat tool called Freestyle. And basically you start with a primitive shape, whether it's a cube or a sphere, and you can basically stretch and pull this shape into whatever designs that you want. One of the examples that I've seen PTC use early on was a pretty cool example of a what you'll call it, laundry detergent bottle. And what's neat about the laundry detergent bottle is it has a circle at the top, as far as geometrically speaking, with a spout, but the whole thing has these, complex curves and surfaces, and the bottom part is somewhat rectangular, even though it's smooth. So you go from a circle into this rectangle, and it's real interesting to see how just being able to model this with Freestyle, you can get it done really quickly and efficiently. So that started with Creo 2.0, and there also have been some more improvements made in the 3.0 version of Creo. So the next thing that I need to get to, and once again, I apologize because I had hidden these slides, and for some reason they're still able to be seen. Flexible modeling. So the other thing that Bruce is going to show you is, for example, a lot of times the longer that you work on a CAD file, the larger it's going to get. So the larger a CAD file becomes, the harder it is to work on. Now the interesting thing about Creo is it's about a third less in size as a finished file. It's a third less than SolidWorks and also Autodesk files. But in addition to not only being a smaller file, with flexible modeling, you are able to make these late stage design changes pretty quickly. So if you'll see in this example, this extrusion here on this part is able to, you'll see it when Bruce does it, it's almost like basically grabbing and pulling in order to move that file. So you can do it in just a few seconds with a handful of clicks instead of it taking over a minute. So when you start to save minutes over late stage design changes, sometimes depending on the change, that could even result into a change of saving hours. So what I'm going to do at this point is I'm going to pass everything over to Bruce, and he is going to do a demonstration, a live demonstration of Creo 3.0. So unlike a cooking show where everything is done, kind of ahead of time, we're going to show you how to do these things from scratch. So Bruce, take it away.
All right. So basically I'm going to kind of go through basically 4 different demos. I'm going to start with just kind of a simple part modeling demonstration, mostly to show you kind of the new look and feel of the Creo interface if you haven't seen it. And then we're going to move on to basically a conceptual modeling kind of demonstration showing the use of the freestyle feature that Rob mentioned. Then we're going to go and touch on MultiCAD. I'm going to show you how you can actually import models from other CAD systems into your design and work with them. And then we're going to end with the flexible modeling demonstration, which allows you to very easily make changes and modifications to geometry, even if it's not native to Creo. So for the part modeling, we'll just start by opening up an assembly. You can't see my screen, is that correct, Rob?
I definitely can see your screen.
All right. So basically, here's a little assembly that has a part in it that's not fully, is not complete yet. If you haven't seen Creo, the user interface is now a bunch of icons and a ribbon. Which is a little bit different than maybe you might have seen. So one thing I can do is I can activate this part, which is not completed. Only about a quarter of this part has been modeled. So we're going to actually activate it, and which allows me to work on the part while I'm in assembly mode. And now I'm simply, we need to create a boss that picks up through the hole in the other part. So I'm just going to create a boss that is on this surface. I'm going to come up here and reference this curve and add that as a reference, and then just sketch a circle, which represents the size of the boss I want it to be. When I come out of it, the sketch, the sketcher is a 2D environment, which allows you to create kind of planar geometry, which you then use to create 3D geometry. I'll type in the height of this boss, and I can also add taper, and let's just add 2 degrees draft on the side walls of that extrusion, and I have it like that. And then finally, let's just go and add a chamfer, maybe to this edge here of a certain size. All right, so that very quickly shows you how you can actually work on parts while you're in the context of the assembly. Alternatively, I could simply pick the part and open it up by itself. Now, what you're seeing here, this is actually skeleton geometry. It's geometry that came from another part. Both this part and the part that sits above it in the assembly Their important design characteristics are being driven by the skeleton geometry. And so if we want to make a change, you can hide that, modify the skeleton geometry, and the changes will be reflected here. All right, on this guy, I'm going to add a little boss on the side face here. I'll come in here and just bring up a palette, and I'm going to use this racetrack shape. Just plop it in here. We'll scale it maybe 0.5, and let's get it. Change the dimensions, change a few of the dimensions, so on and so forth. When I come out of it, let's just give it a height of 0.2, I believe. And we'll also add some 40-degree draft on this guy, just to give it a nice taper. All right, at this point, I'm going to put some rounds on this part. Now, there is built in something relatively new, is an auto round feature, which will automatically round all the edges of the part. However, you can't exclude the edges. So there's a set of edges that someone had created, and I'm going to tell it not to put rounds on those edges. So when I hit the actually perform the feature, it rounds the rest of the part, but leaves those edges go. I do need to add an additional round on this edge. And now, again, this is only a quarter of the part. I can get the rest of the part by mirroring the geometry. So I'll just mirror it about this face. And then if I wanted to, I could come up here and grab the part again, mirror about this face. And now I have the rest of the part. If I close out of it, come back to the assembly, notice that the changes I made to the part are immediately apparent in the assembly. And if I come up here and do a drag, I can notice I can actually rotate that because of the way it was assembled, and you can kind of see how the shuttle mechanism works. Now, someone might actually do a finite element analysis and say, well, when it's moving back and forth, it's stressing too much here. So I might need to add some additional geometry. So let's just open up this. And what we might want to do is put some ribs on here to kind of strengthen this section here. So to do that, I can actually go back into insert mode. And now I'm going to basically add a what's called a trajectory rib. I'll reference the rib from the center point of that boss and just basically just put a line here, and then I'll draw another line, say up to here. I'll take that and mirror that across the center line. Let's shorten that up a little bit. And then maybe I'll just draw a line across here. All right, so that I'm sketching that 2D geometry. When I come out of it, what the trajectory rib does is it takes it and thickens it, and it extrudes it down into the part. I can basically change the shape of it or adjust the width of the rib. I can add draft to it. Let's put on maybe 3 degrees draft, and then I can put rounds on the bottom of the part and the rounds on the top edge of the part. So once I've done that, now I can go in and resume the 2 mirror commands and get the rest of the geometry back, close out of it, come back to this window, let's turn off my planes, and now there's the part. Okay. And again, as soon as you make a change to a part and you come out of it, anywhere where that part is used, whether it's in an assembly or a drawing, subsequent objects are updated concurrently or automatically. All right, so that just kind of is a quick demo of just some simple part modeling. Let's move on and look at conceptual design, okay? Some concept modeling kind of ideas. So I'm going to change my directory to, let me see here, we're going to go to this guy. And this guy we're going to open up, let me first, we'll open up this outside shell assembly. All right, if we look at this assembly, it's basically a shaver head. And what we want to do is we want to actually create some geometry that spans, closes in the gap between the end surfaces here and this front here. If I open up that part, basically it looks like that. So these are simple surfaces that someone had constructed already. And we actually want to basically construct the geometry or a surface that kind of blends or goes from this between here. So we can do that using what Rob mentioned, the freestyle feature. Before I do it, however, I can go into my images here, and I can actually display some 2D images. So I had previously brought in 2D JPEGs. These might have been created by an industrial designer to say, okay, here's the shape of the part I want you to kind of adhere to. So I can just lay them into the part on planes just to give me a visualization, kind of what I'm trying to achieve here. All right, at this point, I'm going to go into the freestyle functionality, and I'm going to start with a sphere. And basically the way the freestyle works is you have a sphere here, but if you notice it's bounded by faces, and I can grab faces and drag them, and when you drag faces, it drags the shape along with it. So you can just basically drag and stretch things as need be. Okay. All right, the shape I want is basically symmetric, so I'm just going to, well, first let me just drag a box around everything. I'm going to go and scale this entire shape down a little bit. Yeah, that looks about right. Okay, so I've scaled it down a little bit. I'm going to pick this back face and tell it I want to mirror that against the right. And what that does is any changes I make to the shape on this side will be reflected in the surface on the other side. Now, I want this shape to join these surfaces in the front and back, so I have to open the shape up. So I'll simply delete these two ends. I'll grab this edge and I'll tell it I want to split that into two pieces. And now I'll simply pick this set of edges here around the control grid, so to speak. And I'm going to align those edges with the edges of this surface. So I'll just do an alignment and to a curve. And basically it aligns that to that geometry. Likewise in the back, I'll basically do the same thing. Pick this edge down to this edge. And now this time I'm going to do an aligned tangent to this edge so that the surface stays tangent with this surface here. All right, let's go ahead. I'll do and say pick this edge. I'm going to do an edge split on it to get a set of vertexes that I can kind of play around with and drag and drop or drag around. I'll go into this view, drag a box, and that just selected all those vertexes on the endpoints of that wireframe grid. And I'm going to basically planarize them in Creo, which just kind of lines them up in a straight line. And then maybe if I grab these sets of vertexes, I can actually drag the shape up and notice it actually is starting to conform to my JPEG in the background. And I might take this edge and drag it up here a little bit. And again, notice as I'm doing this side, it's adjusting the surface on the other side. I may take these two surfaces and split those faces. And now I can do what's called a planarize on them. Well, let's just planarize them relative to this plane. So it actually makes them parallel to that plane. And notice I can actually drag them up if I want to. Let's change my view to look down on top. And now I can just drag vertexes around, again, just to sort of adjust the shape that I'm trying to. Okay. All right, assuming I'm happy with that, I might then pick some edges along here and maybe tell it to crease them. And that, I told it to do a sharp crease, so it put a sharp crease along those edges. All right. Now at this point, you can do some surface modeling now, and then convert this thing into a solid part that then you could drive for the shell of this electric shaper. So that kind of shows you how quickly you can very quickly create some organic shape that you can kind of drag to whatever you desire, but still have that shape correspond to some parametric geometry underneath it all, which you need to do too because we're in a mechanical engineering world. All right. Okay, let's move on to the next example, which is MultiCAD, how we work in a MultiCAD environment. So let me erase everything out of memory and go into this, set that to my working directory. And this one I'm going to open up this assembly here. All right, so with this assembly, basically what we wanted to kind of demonstrate is how we can very easily make use of geometry from other CAD systems. So in this case, we have a part that a lot of these are actually Creo parts. And what we want to do is we're going to actually assemble a motor into here to drive the thing. We're then going to basically assemble a sheet metal part that actually holds the motor in place. We then have to make some adjustments to that sheet metal part because the motor has some tabs on for the contacts, and they poke through the sheet metal part, so we're going to have to create some openings in the sheet metal part and do a few other things. All right. So let's start by come up here. I'm just going to hide this geometry, and I'm going to basically activate the shaver head assembly because that's where I want it to go. Okay, so give me a second here while all right, so I want to basically make sure I get the right one. Okay, so I want to activate this assembly. And now I'm going to basically assemble in a motor. So this is not a Creo part. This actually comes from NX. So basically, I'm just going to use the default constraint, which locates it where it's supposed to be. I'll hit the check mark here. And it gets placed where it's supposed to be. At this point, I'm going to now assemble a Creo model to this assembly. And it's basically going to be a sheet metal part that's actually going to hold this motor in place. Excuse me a second. Kind of had a brain. All right, so at this point, we're going to go and assemble in. And I'm just going to just look for contact. So it comes into the assembly, and I can drag it around. But what we really want to do is we want to associate the right datum plane in this part with the right datum plane in the assembly. We want them to be coincident. We're then going to associate this space in the main assembly with this space here. We want the distance to be 66.3. And now we're going to associate the front to the front, also coincident. It's fully constrained, and now I can bring it in. Now, let me just open up this by itself. Oh, I'm sorry, not that guy. Let me open this guy by itself. And it's a little bit, so you can better see what's happening. And notice here, these the tabs on the motor are actually sticking through the sheet metal part. So what I'm going to do is actually fix the sheet metal part. So I will activate it. And now I'm going to make use of what's called copy geometry. And I'm going to tell it to copy this surface and this surface into the sheet metal part. Okay. If I then, let's reactivate the assembly. If I then grab this assembly and open it, or grab the sheet metal part and open it, notice it has these two surfaces in it, which is were copied from the NX part. Okay. Now to create the opening, I'm going to use what's referred to as a user-defined feature. Okay. So I'm going to go ahead here and under user-defined, I'm going to basically grab this cutout group. So that's pre-selected. I'll say OK. It needs to know the references that it needs to locate itself in the assembly, which happen to be this space, this, and then the back face. Oops, got the wrong direction. Let me instruct that again. Make sure I get it right. Use define, cut out. This. This is embarrassing. All right, let's go back to this model.
Bruce, while you're working, I'm going to interrupt real quick just to let everybody know that I have uploaded into the handouts section of the dashboard 3 data sheets, one on Unite technology, one on flexible modeling, and the other for the top enhancements of PTC Creo 3.0. So feel free to download those at your leisure, and that's my commercial, Bruce.
Okay. All right. I think I picked the wrong one. So let's just try this again. So let's go use define feature, cut out open. I want this space, this. Oh, good. All right, second time's a charm, right? All right, so with that selected, I'm just going to basically do a copy of it, paste special, and apply, move, and rotate transformations, and rotate it about the center axis, 180 degrees, so we get it over here. I'll go and hide this so we don't see the copy geometry in there anymore, and let's just go and save the status. So when I save this part, it saves the fact that it was it. And then I'll come back to here into my main assembly, and let's just exit out of insert mode. There's some additional parts that we want to model. So I'm going to basically pick this this object here, which is under this it's this part, and I'm going to activate it. I'll go ahead and do a copy geometry in it. So I'm going to copy geometry from the motor into that. This one I'm going to tell it not to update it. I'm going to tell it to manually update and let me know that it's changed. And now I'm simply going to pick this surface, and this surface to copy into that part. I'll then grab this sketch and extrude it to, and now I'll pick a quilt, which is this quilt. So the depth of that extrude is being driven by that quilt. And now I can basically, let's just hit Control D, close this window, and come back to my top level assembly. All right, so at this point, I'm going to basically save this assembly away. So it just got saved to disk. And now what I'm going to do is I'm going to show you how we can actually change the motor. Now keep in mind that motor came from NX. So what I'm going to do is I'm going to close everything, erase everything out of memory. I'm going to open up a Windows Explorer, and here's the new motor that's different than the previous motor. The same name, so I'm just going to do a copy and paste it into this directory and tell it to replace it. So I've just manually replaced the original version of the NX model with this new version, Now I'm going to go and open up the main top level assembly again. Oh, I'm sorry, I picked the wrong assembly. I wasn't seeing the motor. Sorry about that, I picked the wrong. All right, so notice
No worries,
I beg your pardon?
No worries.
Okay. Now, if I zoom up here, notice that it's a different motor. The other motor didn't have this blue ridges here. If I do a Control-G, it's going to update the assembly. And notice as soon as I did it, it updated the openings in the sheet metal part. And it did it because I said automatically update upon regeneration. On the other hand, this geometry here did not update correctly. So to fix that, I can go into the notification center and see that I have a component that's out of date. And what's out of date is this guy, this copy geometry. Okay. I can locate it in the model tree. And now I can come up here and say update control, show the differences. Okay. Yeah, I should have probably had. So basically, if I turn off what was changed, originally that surface that was copied into this dampener part was that, okay? And what changed was the shape of the part changed. So I'll just do an update. It's going to update this part. Now this part corresponds and it touches the side of the new motor. And I basically updated this assembly accordingly. So I'm able to swap in a new part that came from a different CAD system, and any references that I had made to the original part carry over to the new part and update accordingly, which is pretty powerful functionality. All right, let me quit out of this and move on to basically a flexible modeling demonstration. And I'm just going to open up this part. Now this is the SolidWorks part. And I simply open it up. I didn't have to do any import. It just opens up directly. Now notice when it does open up, it still comes in sort of as a blob of geometry. Okay, you don't get the SolidWorks features. It's just kind of a blob. But in the past, if you wanted to make changes to this part, you could easily add new features to it, say rounds and what have you. But if you wanted to actually make some changes to the original geometry here, so let's say someone came to you and said, well, can you give me 4 ears instead of 3? So instead of 3 at 120 degrees, I want 4 at 90 degrees. And I want to replicate this boss at the top of the part, at the bottom. And in the past, well, you could do it. It would take a great deal of time. Now, with flexible modeling, it contains functionality to very easily allow you to make changes to a model that wasn't modeled in the native in Creo. Because if it was native in Creo, this was probably a pattern, and you could change the parameters of the pattern and get 4 instead of 3. But because it came from SolidWorks, we don't have that luxury. So I'm first going to basically create a datum axis through the center of that part, because all the movement I'm going to do is going to be rotations. And now I'm going to go into my flexible modeler. I'll basically grab this surface and basically recognize it as a boss. And now I'm going to move it relative to this axis. And notice I can actually drag it, but I really want it 15 degrees. So I've just rotated that ear 15 degrees. I'll do the same thing with this ear. and likewise rotate it this direction 15. And that makes them 9 degrees apart. I'll come here down and grab this guy, move using a dragger relative to here, and then I'll move him 45 degrees, because again I wanted 4 of them 90 degrees apart. And now I'll just re-grab this one, move it relative to this, .90 degrees, but I'll tell it to leave a copy behind. So now, I don't know, I haven't been timing myself, but in maybe about a minute or two, I was able to change that fairly easily to give me 4 instead of 3. All right, if I want to replicate this, it's pretty much the same way. First, I don't really need this hole, so I'm going to recognize that as a cut and remove it. And now I'm going to come up, grab this guy, and basically recognize it as a boss. However, I don't need these 2 surfaces, so I'll just kind of deselect them. And at this point, I'll do a similar move relative to this, help to leave a copy behind, and rotate this around maybe 180. And there I've replicated that. Other things that you can do, if we wanted to change the diameters of those holes, I could maybe pick this diameter here, recognize that as a cut, and then I can make use of this pattern recognition feature. And it picked up these holes as members of the pattern. It says, hey, they're the same diameter as the original. You probably want them to be a pattern. And now I could maybe grab this hole, modify analytic, and let's maybe make it a little bit larger. And notice just that one gets larger, but if I wanted to, I could then say propagate that change to the rest of the pattern. And now the rest of the pattern's been changed. At this point, if I wanted to, I could then say save a copy and save this back as a SolidWorks part. And I'll just say Ref 2. And basically it would get saved as a SolidWorks part, and then someone could open it up into SolidWorks. So you could very easily, using this unique technology, you can very easily collaborate between people who are using different CAD systems. So I think that's about it. Why don't we open the door for open it up for questions? Hopefully, Rob, are you still there?
Oh yeah, I'm still here. What I'm going to do, Bruce, is I'm going to take control back.
Okay.
And actually, if you could pass me control.
Okay. I can go.
Okay, so I'm going to try this again. Hopefully this will work. When you see my screen, Bruce, are you seeing, like you see down here it says slide 2 of 29?
Yes, I do.
All right, because I have 2 screens and I don't know how to, let me see if I can change. Let me go to monitor 2. There we go.
One.
How's that?
That's better.
Good. Fixed the problem, folks. Sorry about what happened earlier. So anyway, in relation to the Pro Engineer offer for specifically for Pro Engineer users, basically it's a trade-in. In the past, usually what PTC required was everybody paying back maintenance. Then they had a win-back program, which was eliminated last September. Last September 30th, the win-back program was eliminated. And this new program, which also ends this September 30th, is basically giving customers the ability to trade in their expired maintenance or their expired license of Pro Engineer to upgrade to Creo 3.0. Now this goes from a perpetual license to a subscription model. And this subscription model includes support and e-learning for the first year. So if you're on or if you have a base license of Pro Engineer Wildfire 4, 5, or whatever, everything that you saw today is in the base package, which is called Creo Essentials. So a Creo Essentials license is about $7,500 for a new license. That includes the first year of support. A subscription for Creo Essentials floating is $2,700 a year. Now the offer for Pro Engineer customers with the expired maintenance is they can upgrade for $1,500 a year, and that's ongoing. So it's not like you pay $1,500 this year and then $2,700 next year. It's $1,500 a year ongoing, and that includes support and also e-learning for the first year. Now the other part of this option is you have the opportunity to trade up to another Creo Essentials package, which would be 75% off of the perpetual license price. So how that would work is if you wanted to move to another package, say Creo Essentials Premium, and these are the Creo Essentials packages. So basically the base model, you have direct modeling with freestyle as well as flexible modeling and Unite technology. Essentials Plus includes product data management with Creo Windchill Essentials, and Essentials Premium includes some simulation capabilities as well as piping and cabling. And Creo Essentials Team does not include the product data management or simulation or piping and cabling, but does include what's called advanced assembly for concurrent engineering capabilities. So product data management, this is a pretty basic product data management. This is not product lifecycle management, but it does help you manage files, bill of materials, and other associated documents. And I'm going to fly through these because if anybody has any questions, I'll detail that at the end, or if you want to talk more one-on-one after the webinar, I'd be more than happy to do that. For Creo Simulate, the simulation in the Essentials Premium package includes solid beams, shells, masses, and springs, as well as design optimization. It does not go into, clearly it's all linear analysis, so it doesn't go as deep as the simulation extension does or advanced simulate. Piping and cabling, pretty self-explanatory. Just providing you a 3D piping and cabling environment in your design so that you can basically go back and forth between schematics from 2D into 3D to help automate your design process for piping and cabling. With advanced assembly, this allows you these comprehensive capabilities for concurrent engineering and top-down design. So you can have a couple of people working on the same, within the same environment as once. If you have multiple licenses of Creo, this would allow two people to be able to work on the same assembly at the same time. And that is it for the overview of the packages. So for example, the Creo Essentials Premium package, if you were to buy that with a new license, as a new license with 1 year of support, that would be $12,565. The subscription price is $4,450. But through the offer, through this PTC Get Active offer, the monthly subscription price would be $24.75 for Creo Essentials Premium. So that's over $2,000 a year less than what the normal price is. So these are pretty aggressive prices from PTC. for customers that we would like to see continue using PTC and move up to the latest and greatest with Creo. So a question that came in, Bruce, was, is Creo 3.0 backwards compatible? Can I send files in a 2.0 format to those who have not upgraded?
No, you cannot. So Creo and ProEngineer has always been upward compatible, so you can always go from earlier releases to latest, but you cannot go from the latest release to earlier releases.
So if somebody does have 3.0, he could send them the 2.0 files. Is that correct?
No.
No? Okay.
The 2.0 files can be read by 3.0, but 3.0 files cannot be read by 2.0.
Correct. Next question, does subscription model always give you the latest version of Creo?
Well, only if you continue to update your installed version.
I think that's a good question, Bruce, because we have Creo 4.0 that's coming out, and it's going to be coming out, I guess we'll know in October what the release date's going to be on that. So if Creo 4.0, say, comes out in January, if you're on a subscription, yes, you could move up to Creo 4.0, but you know, like with any other type of software, you want to know what the bugs and everything are going to be before you actually make the change. And Creo 3.0 is a proven software. So I think,
but it's not automatic in the sense that your version of Creo on your local system changes. You will have to download the latest build and install Creo 4. But you should be able to do it with a subscription.
now somebody for some reason wanted Creo 2.0 as a subscription model. Would they be able to do that?
Yes. You could download an earlier version of Creo and run an earlier version if you so chose. Yes.
All right, good deal.
If you worked with customers who had Creo 2, you might want to stay with Creo 2 until they move to Creo 3. So you have to kind of plan your upgrade path because of not being able to send things to earlier versions of Creo.
So those are the only two questions that we've had come in. Here's another one. Is it possible to run multiple versions on the same computer?
Yes, it is. You just install it. I have, at this point, I think I just have Creo 2 and Creo 3. I actually might have Wildfire 5 on here too. So yes, it is possible to have multiple versions. Yes.
Good deal. Well, we are just about at the top of the hour. So Bruce, I want to thank you for your time and doing a fantastic demo as always. And I'd like to thank everybody who came out today. If you have any questions, you can respond to the email that was sent with the notification to this webinar, which is marketing@3hti.com. You can just reply and ask any questions that you would like, or you can contact us at info, I-N-F-O, at 3hti.com, and either myself or one of our account representatives will get back in touch with you with more information to help answer any questions that you have. And if you want to take a closer look at Creo, if you would like a more detailed one-on-one presentation for something that you're doing specific, we're more than happy to help you with that. So thanks again, everybody, for being on. Thank you, Bruce, and enjoy the rest of your day. Thanks, everybody.